This question lebih kurang sama je macam example number 1. However, what's given here is the UV section. Instead of you have to suggest for the section, this question give you the section for you to check. What we do is check on the loading. Kita akan tengok on the UDL dululah. UDL for that load is 7 kilonewton per meter and UDL for imposed load is 6 kilonewton per meter. Darab dengan the length of the beam which is 5 meter and kita baru tambah the point load which is the imposed load Then kita kira separately 5 meter tu jangan darab dulu. 19.4 kilonewton per meter darab dengan 5 meter plus 40 kilonewton. 137 kilonewton. Kira on the bending moment and shear force. We know that the beam is symmetrically loaded because of UDL is along the length of the beam and the point load is exactly at the middle ataupun center of the beam. We have RA and RB sebab these two adalah reaction. Point A and point B. Just take the ultimate load, you divide it with 2. You will get 68.5 kilonewton for each reaction dekat point A and point B. We know that this value also adalah FV, which is the maximum shear force. Then we calculate for moment WL square over 8 plus WL over 4. You can use some other WL square over 8 ataupun WL over 8 depends on the unit of the UDL yang you pakai. Length dia 5 meter, power of 2 divide with 8 plus 40 kilonewton, 5 meter divide it with 4. Azim?
110.625.
Correct. Betul, thank you. This is our maximum bending moment. Next, tak payah assume sebenarnya. Sebab dia dah bagi section. Since the section kita 305.102.28. Then we look at kat mana 305.102.28 ni daripada this table. Soalan suruh you pakai, jangan ambil section lain. Check dia punya T 8.9 sebab kita nak tahu the value for PY. Bila T is less than 16 which is the first one PY 275. Dan kita boleh confirmkan balik SX ni okay or not, kita kira SX walaupun kita dah ada suggested section. SX equal to moment divide with steel strength. Our M is 110.625. Tukar dia into Newton millimeter. Divide it with 275. 402.727 millimeter cube equal to 402.273. Ini SX yang kita kira. SX for this section which is 305.10 ni berapa? Plastic modulus for our section here is 407. Tengok dekat SX Kita compare plastic modulus yang kita kira dengan plastic modulus of the section. Okay atau tak? SX yang provided by the section is bigger than SX yang kita kira. Which should be kalau kita compare macam dalam example number 1, it should be okay lah sebab kita provide lebih besar. Okay, terbalik. Okay, strength classification. Constant is equal to 1 B over T and D over T to make sure that the beam is plastic. Look at the table again. B over T is 5.72 and D over T is 45.2. Dari dua value ni, we actually need to refer to this table. For this one, kita akan compare starting dari plastik dululah. B over T is memang less than 9 sebab constant kita 1 9 times 1 jadi 9 juga. B over T 5.72 is less than 9 and D over T 45.2 is less than 80. Kita akan dapat section is class 1 plus we do shear strength. D over T is 45.2 which is less than 70 constant because of our section is roll I section. Kalau welded section kita compare dengan 62 constant. Shear buckling need not be considered. Kita kira PV 0.6 PYA which is kalau kita pakai roll I section A2 equal to TD, masukkan je value PY 275 and the value of T and D we have to refer in the properties of UB again. Small t and capital D. 6.1 and 308.9. 310,907.85. This one is in Newton. Kita convert into kilonewton. Value ni kita boleh compare dengan value FV. Our maximum shear force here is 68.5. Ini adalah FV is exactly less than PV. Our PV is 310.908 which means low shear load. Kita masuk on the bending moment. Moment capacity which is MC equal to PY SX. PY 275. SX of the section is 407 centimeter cube.
Yang shear strength tu kenapa dia less than 70?
Shear stress mana ni?
Shear buckling tu nak 70.
This one shear buckling. Bukan this one Ini untuk you classify. Ini untuk you check shear buckling. For shear buckling, untuk steel beam, for roll section, you akan compare dengan 70 constant. For welded section, you akan compare dengan 62 constant. Okay, ini memang dalam BS. Dia tak ada kena-mengena dengan classification tu
Okay.
SX is 407 centimeter cube. Tukar dia into millimeter cube. Darab 10 kuasa 3 lah. 111,925,000. Newton millimeter equal to 111.925 kilonewton meter. Kita kena juga compare MC ni dengan 1.2 PYZ 1.2275 and Z is elastic modulus. Tengok pada section ni lagi 351 centimeter cube. Kita akan tukar dia into millimeter cube darab 10 kuasa 3 lagi 115.83000. Newton millimeter 115.830 kilonewton meter. Compare kan kita dapat 1.2 PYZ is bigger than MC or MC is less than 1.2 PYZ. Sama je Therefore, okay, kira moment due to the loading, the moment due to self-weight of the beam. 110.625 ni, kita nak kira moment due to self-weight. MSW equal to, kita tahu self-weight dia adalah UDL, WL square over 8. Weight dia adalah dead load. So kita kena darab dengan factor of safety for that load 1.4 darab dengan dia punya weight lah. Which is kita tak ada, kita just ada mass sahaja for the section 28 kilogram per meter. That is mass per meter ya. Darab 28 kilogram per meter. Ini dalam mass. Convert dia into Newton darab dengan gravity acceleration. We have to divide with 1000 nak tukar ke kilonewton. This is all untuk W Kita darab dengan the length of the beam which is 5 meter. Power of 2 divide with 1.202 kilonewton meter. Total moment MT. Campurkan moment due to the loading plus dengan self-weight moment and kita compare this total moment dengan moment capacity of the beam. MT is less than MC. Sikit je the value beza dia tapi okay sebab dia as long as dia less than MC meaning that the beam boleh resist the moment yang caused by loading Proposed section is suitable tu ada markah tau. I'm going to end the class here. Bye guys. Thank you.
Thank you, Miss.
Thank you, Miss.